Hello, this is Scholar Strife doing some math today in geometry. We're going to be looking at trigonometric ratios, specifically sine, cosine, and tangent. So this is not sin, cos, and tan. This is sine, cosine, and tangent. These are keys that you can find on most calculators. Your phones should have them as well. And all these are ratios comparing different sides of a right triangle. So we're going to just look at tangent today, or this time. Tangent of an angle, so we call that angle theta. Theta kind of looks like a Pokeball, a little bit. And the tangent of theta is always the opposite leg over adjacent leg. So let's look at the pieces of a triangle. So if I wanted to do the tangent of angle A, so I would say tangent of A. So here's my angle. My angle is right here. So I'm just going to call it theta. So there's my angle there. And if I wanted to know tangent of A would be equal to the opposite leg. So you start at your angle and go to the opposite side of the triangle. So that would be opposite leg, which is, in this case, the length of CB, over the adjacent angle. Adjacent means next to, but not the hypotenuse. Okay? So remember, in a right triangle, there's two legs and a hypotenuse. The hypotenuse is always the longest side opposite of the right angle. And then the other two are just legs. Okay? So if I'm looking at A, the leg next to A is the distance from B to A. Okay, that is the adjacent. Okay, let's use some numbers here. So find the tangent of angle S and the tangent of angle R. Write each answer as a fraction and as a decimal rounded to 4 decimal places. Okay, so tangent of angle S. Now when you're doing these, because we're going to work with sine and cosine as well, it's always good to label the sides that you have. So for example, we're looking at S, right? So I'm going to circle that, and I'm going to label all my sides compared to S. So from S, this is my hypotenuse, because it's always the hypotenuse. It's always the longest side. It's opposite of the right angle. Opposite side of S, okay, so I'll just go from my angle to the opposite side of the triangle. So my opposite side of S is 60. And my adjacent side would be the last remaining one, is 25. So tangent of S is equal to opposite over adjacent, which is tangent of angle S is equal to 60 over 25. Okay. This will reduce to 12 over 5. And then if we do it as a decimal, the tangent of angle S is 2.4. Okay. So let's do tangent of R. I'm going to do it in a different color. Let's go blue. So tangent of R. Okay. So here's r. My hypotenuse is still the same. Okay, but my opposite and adjacent side are going to be different because r is located in the bottom right, so the opposite side is the 25 over, what's the side next to r? That's not the hypotenuse, and that would be 60. So in this one, this is the opposite side, and this is the adjacent side. If we reduce this, this will still be 5 over 12 now, and this will give us a decimal. So tangent of r is equal, or approximately, 0.4167. Okay, so let's do another one. Alright, tangent of b, so I'm going to circle b. So I want to find the tangent of b. It is the ratio of opposite over adjacent side. Okay, so tangent of b is equal to, here's opposite side, because that's the opposite side right there. 48 over adjacent. What's the side that's next to? Okay, that's 14. And this will round to 24 over 7, which is approximately 3.4286. Okay. Okay, now we want to do tangent of C. Okay, so C is right here. Opposite end is 14. The side next to it, but not the hypotenuse. Hypotenuse has always been this side. 48. So I'll get 7 over 24, which is about 0.2917. Alright, find the value of x. Okay, so they give us an angle. Okay, and since we're learning about tangent, we're going to use tangent. Okay, so tangent of our angle is 31 degrees, is equal to opposite side. Okay, so this is hypotenuse. This is my opposite of my 31 degrees. And then my last remaining side is my adjacent, which is right next to it. Okay, so tangent of 31 degrees is 17 over x. Okay. So what we're going to do is, to get x by itself, I'll leave this in a different color. We're going to, since x is in the denominator, we're going to move it out of the denominator by multiplying both sides by x. So x times the tangent of 31 degrees. So tangent of 31 degrees is just a number. You can try it out in your calculator. So it's just a number being multiplied to x. And 17's over here. Okay. So we have a number being multiplied to x. So we're going to get rid of it by dividing by that number. That number is tangent of 31. So I'm going to divide both sides by tangent of 31. These will cancel. Okay, and then I'm going to be left with x equals 17 divided by the tangent of 31 degrees. So I'm going to go to my calculator. Tangent of 31 degrees. So I'm going to go to my calculator and do 17 divided by tangent of 31 degrees. And I'm going to get 28.29 28. So 28.2928. Okay. Now, if you're having any issues with your calculator, like you punch this in, and for some reason you're not getting the same number as me, make sure you go to your settings in your calculator. It might be the button called Mode, or it could be some sort of setting on your calculator. And what you want to change is there is a thing called radians, and then there's a thing called degrees. Make sure that the degree is highlighted because we're using degrees. Radian is another form of measuring angles. But we're using degrees. So make sure degrees is highlighted. Some of your calculators, you might see a DEG in the corner. That is fine. As long as it doesn't say RAD. If it says RAD, then you will get a different answer. Which is not the correct one. Because we are using degrees. So if you see DEG, you're good. If you see RAD, figure out how to change the settings on your calculator, because all of them can do it. Well, if they have a sine, cosine, and tangent button, then they should be able to do it. You should be able to change from either radians to degrees. All right, let's move on to the next example. Find the height of the lighthouse. Okay, so we have an angle here. So we're going to do tangent of 62 degrees equals opposite side. So here's my opposite side, here's my hypotenuse, here's my adjacent side. Okay. So tangent of 62 degrees equals opposite, which is h, over 100. Okay, to get h by itself, we just multiply both sides by 100. And we'll get 100 times whatever the tangent of 62 degrees is. And that will be... So tangent of 62 times 100 . 188.0726 feet. Okay, example 4. Use a special right triangle to find the tangent of a 30 degree angle. Okay, so if you remember from last time, we have a special right triangle where it's a 30, 60, 90 degree triangle, and it follows this pattern. Opposite of the 30 is x, the hypotenuse is 2x, and opposite of the 60 is equal to x root 3. Okay, so in this case, this x value is equal to, here I'm going to change this to z. So z is equal to x root 3. Okay, and this is equal to my x, because this is opposite of 30. Okay, so that means that z here is equal to square root of 3 times the square root of 3, which is the square root of 9, which is 3. Okay, so tangent of 30 is equal to opposite, which is square root of 3, over 3. So tangent of 30 degrees equals this. So that's all they were looking for. They were looking for the tangent of a 30 degree angle. Remember, tangent is the ratio. Checkpoint 2. Here we go. So we have 63 degrees. So we're going to do tangent of 63 degrees equals 13, the opposite side, over the adjacent side. Because remember, hypotenuse is always opposite of the right angle. So this is 13 over x. Okay, I'm going to multiply both sides by x to get it out of the denominator. And we'll get x times the tangent of 63 equals 13. And then tangent of 63 is just a number, and it's being multiplied to x, so to get rid of it, we're just going to divide by that number. These will cancel, and then we're left with x equals 13 divided by tangent of 63, which is approximately 6.62. And they want nearest tenth, so 6.6. Okay, next one. Here's our angle, so tangent of 59 degrees equals opposite over adjacent. So this time our hypotenuse is on the bottom because it's opposite of the right angle. So opposite side of our 59 degrees is x. Adjacent side, or next to our 59, that's not the hypotenuse, it's 21. Multiply both sides by 21. And we'll get x is approximately, so 21 times the tangent of 59 is about 34.95. I have to go check the work here. 21 tangent 59. Okay, this is 34.94. So this will round to 34.9. Hopefully this helped you out. Have a good day.